Hey all, and welcome to another video. Today we will be talking about COVID-19 and a molecule called lactoferrin. This is actually requested by one of the viewers to go over kind of the evidence behind lactoferrin in an antiviral standpoint and also as related to COVID-19. So we're going to be talking about lactoferrin just in general, what it is, how it works, and then also we're going to be talking about some proposed and studied mechanisms of antiviral activity for lactoferrin, and then resultantly we're going to transition into kind of experimentally what we know about lactoferrin and coronaviruses in general. So to start with, lactoferrin, which we're going to abbreviate LF, is a glycoprotein that is produced naturally in the body by many glandular cells. So glandular cells. You can find it in most human body fluids, tears, breast milk, etc. And it is a part of the transferrin family. Transferrins are iron transporters. So lactoferrin, transferrin kind of makes sense with the name. So they're iron transporters. There's actually 3 different forms of lactoferrin. There's a lactoferrin alpha, which is the iron binder. And then there's lactoferrin beta and lactoferrin, which are ribonuclease, have ribonuclease activity. So these are the 3 different, isoforms, 3 different forms of lactoferrin that are present in the body. And this lactoferrin alpha is the traditional one that we think of, which is the iron binder. Lactoferrin kind of has this double shape, and each one of these sides actually binds iron. So each lactoferrin can bind 2 different iron molecules. They bind them really tightly, which means that even at low pHs, they do not release them. So bind tight to iron. The reason I brought up the low pH thing is because in infected tissues, there's going to be a low pH in those tissues, and the lactoferrin will still hold on to that iron. It's important to note that iron is tightly regulated within human bodies by transferrin. So transferrin typically tightly regulates iron levels. Transferrin tightly regulates iron levels in the body, but one of the proposed anti-microbial mechanisms is that bacteria and such need iron to function. So by increasing lactoferrin levels and increasing iron binding in the body, those microbes will no longer have that iron, and thus they can't propagate infection. The caveat to this, though, is that some bacteria, which we'll draw kind of by this oblong shape, have evolved to actually utilize lactoferrin and get iron from their lactoferrin. So they'll actually have a lactoferrin receptor, excuse me, that will look for this lactoferrin in the body, find it, and then it'll chelate off the lactoferrin iron, and that's how it will get the iron in their body for the bacteria. So although there is still proposed mechanisms that lactoferrin will get rid of excess iron and thus inhibit bacteria from getting that iron, some bacteria have evolved to say, okay, you're going to do that, well then I'm going to grab the iron off of lactoferrin. This is not the mechanism proposed for the antiviral activity portion. So why are we talking about lactoferrin in COVID? Well, experimentally, there have been a handful of experiments relating to COVID-19, mostly in coronaviruses in general. So we've seen inhibition of viral entry via, and we'll talk about this more, heparin sulfate proteoglycans in murine coronaviruses. We're just going to do coronaviruses CV. And that was studied by Han et al. In 2005. We also have seen inhibition of viral entry via heparin sulfate proteoglycans in human coronaviruses, specifically the human coronavirus NL63. And that was studied by Milweka et al. In 2014. So both murine and human coronaviruses. And then lastly, we actually saw the same thing, inhibition of viral entry via heparin sulfate proteoglycans in the human coronavirus SARS-CoV or SARS-CoV-1, which is, known as SARS, and that was studied by Lang et al. In 2011. So we do have this pool of data that shows that in different other coronaviruses, lactoferrin has inhibited viral entry. Let me just mute my computer here. Via this heparin sulfate proteoglycan mechanism in murine coronaviruses, human coronaviruses causing the common cold, such as this one, and also SARS-CoV-1. So because of that, there's actually a clinical trial going on right now. It's called, I'll just write it out quick, Efficacy and Safety of lactoferrin as an adjunct, as a therapeutic adjunct agent for COVID-19. And that's currently going on, so we obviously don't have any data from that, but there is a clinical trial looking at this exact question. So experimentally we've seen this, but what's the mechanism? And the mechanism that they found was this heparin sulfate proteoglycan, but there's actually all other mechanisms that they've seen in different viruses of how lactoferrin could inhibit viral propagation. And that's kind of what I wanted to talk about for the rest of the discussion here, was that these mechanisms that we've seen in other viruses in lactoferrin that may be applicable to COVID-19. So I'm going to draw a human cell membrane here, and that's what this is. This is going to be human cell membrane. And then we're just going to draw some things that you guys might be familiar with from other videos. So this is going to be the ACE2 receptor. ACE2 receptor. In blue here, these are going to be heparin sulfate proteoglycans on the cell surface. Then we're obviously going to have our virus here, SARS-CoV-2, which causes COVID-19. And what we have seen is a few different things. So one, let me just do lactoferrin, will be in black. And I'm going to draw another virus just out this way so I don't clog up the screen too much. So one mechanism they've seen is actually direct inhibition by attaching to the virion itself. And this was seen in actually hepatitis C virus. So in hepatitis C virus, they found experimentally that lactoferrin binds to the virion, the virus itself, and inhibits viral entry through that direct binding mechanism. All right. And then in SARS-CoV-1, as well as several other viruses, they actually found another mechanism of viral attachment. So we've talked a lot about SARS-CoV-2 attaching the ACE2 receptor. As SARS-CoV-1 does the same thing, but they also found in SARS-CoV-1 that there's this kind of intermediate step where the virus comes and softly adheres to heparin sulfate proteoglycans, and then that slows the virus down, and then the virus does its final attachment to the ACE2 receptor. So they found this mechanism where heparin sulfate proteoglycans, oh that's a P, it kind of looks like an R, heparin sulfate proteoglycans start this kind of soft cell adhesion that slows the virus down, and then the virus, they called it, surfs over to the ACE2 receptor. Well, what lactoferrin does is it actually binds to all these heparin sulfate proteoglycans so that they're not available for the virus to bind to, and thus you can't get this surfing over to the ACE2 receptor. And they found that in actually SARS-CoV-1 as a mechanism of viral inhibition. And then the last thing they found was, so right, you have all the RNA. Once it binds, it gets into the cell in an endosome with this RNA, and then it dumps the RNA into the cytosol. Well, what they found actually in HIV was that there was a step in here that they couldn't identify that inhibited intracellular viral replication. And I'll just underline that. That was in HIV. So basically for lactoferrin, there's this clinical trial, and the clinical trial is being studied because lactoferrin has been found to, one, directly inhibit, circle with a cross through it, viral adhesion, and that was seen in hepatitis C virus. It also was found to bind heparin sulfate proteoglycans, which inhibited viral adhesion, and that was actually seen in SARS-CoV-1. And then third, it's been seen to inhibit, oh, let's just stay consistent with my circle with a cross through it, inhibit viral replication in the cell, and that was seen in HIV. Lactoferrin, though, does have another mechanism that people postulate may be of value in COVID-19 specifically, and that's through immunomodulatory anti-inflammatory effects. So we know in COVID-19 we get this hyperinflammatory response. And that hyperinflammatory response is secondary to all these inflammatory inflammatory cytokines, interleukin 1, interleukin 6, interleukin 12, tumor necrosis factor alpha. All these are cytokines which increase the inflammatory response. Let's do inflammatory response. What lactoferrin has actually been seen to do in, excuse me, in several sepsis studies, and sepsis is just a systemic infection. So in several sepsis studies, lactoferrin has been seen to decrease interleukin 6, tumor necrosis factor alpha, and ferritin levels. And ferritin is another inflammatory marker that we see elevate in COVID-19. So there may be some inherent immunomodulatory effects of lactoferrin given that they see decreased levels of these inflammatory cytokines in sepsis models. So that is kind of the alternate pathway that they propose lactoferrin could be of use in COVID-19, is through this secondary immunomodulatory pathway in addition to its direct antiviral effects. So obviously the normal precautions, this has never been studied in COVID-19. There's no evidence to firmly suggest that it is helpful. The video is simply for educational purposes. It is not a clinical recommendation. Don't start taking lactoferrin because of this video. Talk to your physician to further elucidate whether it could be of benefit for you specifically. In any case, we will see what that clinical trial shows, the efficacy and safety of lactoferrin as adjunct to therapeutic agent for COVID-19, and see if there's any additional data out there on lactoferrin. Hope you enjoyed the video. Let us know what questions, thoughts you may have. Feel free to subscribe if you feel inclined, and we will see you all next time.